Dear student, Assalamu alaikum. I'm Dr. Muslim Khan, Assistant Professor, Department of Chemistry, KUST. Today, the topic of our presentation is the second part of electrophoresis. Today is the eighth lecture, and course is chromatographic and electrophoretic method of analysis, and the course code is CHEM455. First of all, what is gel electrophoresis technique? Uh, Use of gelatinous material. Gel is used and gel electrophoresis technique. So the gel act as a support medium in gel electrophoresis technique, used to separate mainly proteins and nucleic acid in this gel electrophoresis. So what are the different types of gels that are used in starch is used as a gel in a gel electrophoresis technique. Uh, Polyacrylamide proteins, small nucleic acid fragments are used as a gel in gel electrophoresis. Also, agarose nucleic acid, large protein. These two are the main, like these are the commonly used gel types in gel electrophoresis technique. And the last one is cellulose acetate protein gel is also used. Cellulose acetate, which is called cellulose acetate electrophoresis technique. So the first one is agarose gel electrophoresis. This is agarose specificity. This is the structure of agarose. You can see it here. So this is technique is easy, very fast, and well-established method for the separating DNA fragments. This agarose gel electrophoresis technique. Agarose, this is a polysaccharide derived from the seaweed, this agarose, and this beta 1,3 D galactose uh, uh, 3,6 and hydro alpha 1,4 galactose. And this dissolve in a boiling water and hardens, become gel when cooling. So basically this molecule is put in a boiling water, it becomes hard, and it becomes gel when you are cooling this. So the advant this is having a bigger pore size than polyacrylamide. Um, mm, it can be advantages sometimes, but can be disadvantages sometimes as well. So whenever you want to separate, as I told you in last lecture, this one, that this is well-established method for DNA fragment. So whenever you want to separate DNA fragment, this agarose gel concentration, this is just this was just for whenever you want to do DNA separation, you must know that how much concentration of agarose I should use. This is just like point 3 of for this size of DNA fragments, and zero point 0.6 for this size of DNA fragments, and zero point 0.7 for this size, and zero point 0.9 for this size. So depends that which size of DNA fragments you are basically separating. You should use that concentration of agarose gel in your experiment. So the next one is a page, polyacrylamide gel electrophoresis. This is acrylamide. This is acrylamide, and this is treated with this molecule, and this become polyacrylamide, means become polymer. Uh, this is a synthetic polymer, as I told you. This is a polymer, and formed from acrylamide subunit. This is acrylamide subunit. This formed from this, and acrylamide with a cross linker, methylene bis acrylamide. This is cross linker, and polymerization catalyst is used, and this ammonium persulfate plus tetramethyl ethylene diamine uh, and light, and 3.5 to 20% concentration, and high resolution. And acrylamide is one thing you know, that acrylamide is a dangerous neurotoxin, so you should be careful of using this acrylamide while doing your experiment. So buffer is also used in electrophoresis. What is the purpose of a buffer? So it provides ion in a solution for electrical conductivity. This is used as a medium. This aqueous buffer is used as a medium and for electrical conductivity. So it prevents the pH changes, because once the pH is changing, then at a change pH, the molecule, the charged particles are basically, the charge is changing then, because at a pH 7, at a pH 9 or pH 3, so they will be in a different form, ionic form. That's why it prevents the pH changing. Also, it needs, it provides the electrical conductivity as well. So common using buffers are tris borate ADTA stable, expensive. This but long separation time. This is used for page. Tris acetate EDTA, inexpensive, short separation time is saving. And tris phosphate EDTA in RNA. Sodium phosphate buffer is also used, and these are other buffer solutions which are used. So we have started this gel agarose electrophoresis. This is electrophoresis gel apparatus. This is how it looks like. This is a flat bed. You can see this is a flat bed electrophoresis, horizontal. In this one, gel thickness is limited. Only one gel per apparatus is used. This is easily adopted to different techniques, easily can be adopted. This is a very technician friendly, means technician can easily repair it. This is more safe for electricity accidents, and generally used for agarose gel electrophoresis technique. Electrophoresis gel apparatus, this is the last one was horizontal, and this is the vertical one. And this one, different gel thicknesses can be used. Each one is having its own advantages, and more than one gel per apparatus can be used in this vertical electrophoresis gel apparatus. So, but on the other hand, this is not very adaptable to different techniques when you want to connect this to different techniques, and also not very technician friendly, this electrophoresis technique, and generally used for polyacrylamide gel electrophoresis technique. So, what are the steps involved in this electrophoresis technique? First of all, sample preparation is needed. In each technique, you know that sample preparation technique is needed. You have to prepare your sample according to your instrument, and then you have to prepare the gel of suitable concentration, what you want to separate basically according to your need, and then the buffer of your desired pH, what you want to separate, and in which state it is your molecule is present. So buffer is present, and etc. And load markers, and then load samples, running of the gel, and the staining of the gel, photography of band and gel documentation, and then interpretation and analysis of gel, what you got from electrophoresis technique. But don't forget, when you want to separate a DNA, so DNA molecule is organic acid. It is negatively charged. So when it is negatively charged, for sure it will migrate toward the positive electrode like anode and electromagnetic field. So small fragments of DNA go further than large fragment of DNA. So don't forget running of the gel, cut off electricity before taking gel from apparatus. The next one is protein electrophoresis. Protein in the gel stained by Comessi blue dyes and silver staining and other like fluorescence and commercial dyes. So other protein electrophoresis technique, one is this isoelectric focusing. They separate protein by their isoelectric points by using pH gradient of the gel. pH gradient of the gel is used in this technique. Other one is 2D page, two-dimensional gel electrophoresis technique is also one of the type of protein electrophoresis technique. It separates proteins by two properties uh, and the mixture. And this Western blotting separate protein first by size, then staining with specific antibody like antigens reactions. And techniques gives molecular weight and identify specific proteins. This pulse field gel electrophoresis technique, this is the picture of used for separating very large DNA molecule. And the size is given. So based on the periodically changes of direction in the electric field, and this is generally used for genotyping and gold standard in um, epi, epidemiological studies of pathogens organism, this pulse field gel electrophoresis technique. Capillary electrophoresis techniques process a large number of samples than classical techniques. A main technique first described by Hitcherton in 1967. The first commercial capillary electrophoresis instrument was available in 1988. Principle is it needs power supply. This is like a sample, and this is a buffer solution, and with sample this anode is there, and also in buffer solution. And next one, this is a detector, cathode is there. This is a data acquisition computer is, and power supply is given to this. So the anode and cathode buffer reservoirs with corresponding electrodes and the separation chamber capillary tube and the injection system and the detector. This is the main principle of this. And then how the different charge bodies are moving towards their respective electrodes and depends on their masses and their shape, size, etc. What we will discuss in our last lecture. So this will migrate towards their respective electrode and then they are separating from each other. Capillary electrode, the application of capillary electrophoresis, this analyzing proteins in physiological matrices like serum, urine, used for the DNA-less analysis. This CE is used for the drug screening as well. Analysis of pesticides, food contents, pollutants, all these things can be analyzed by capillary electrophoresis. Specific application, these were the general application for the neoplastic disorder, detection of tumor-related mutation can also be studied by this capillary electrophoresis technique. Microsatellite instability, analysis of monoclonality, diagnosis of hereditary disease and parental testing, diagnosis of infectious disease, identity testing. So it can be used as a qualitative technique as well. So, like coming again to the general form of electrophoresis, in most electrophoresis unit, the gel is mounted between two. As I told you that I will show you in the future. Uh, the gel is mounted between the two units. The gel is mounted between two buffer chamber containing separate electrodes. This is a different chamber. This is a different chamber. This anode is there in this chamber. Cathode is there in this chamber. So the gel is mounted between two containing separate electrode, so that the only electrical connection between the two chambers is through the gel. Uh, this is also one of the picture of this technique. So like this is a cathode and buffer solution and upper reservoir. This is lower reservoir, anode and lower reservoir. These are the two reactions taking place at respective electrodes. H2O converting to hydrogen ion oxygen plus two electrode, and this one, these two electrodes were taken by hydrogen H2O and hydroxyl hydrogen, and this is how organic acid converted into respective anions, and this is how this organic acid again these anions combine to form this organic acids. So this is the technique showing, or you can show it by this way as well. That's how this technique electrophoresis is working here. These are the different tube gel units. As I told you that I will show you the picture of tube gel units. This is the tube gel unit, and this is the slab gel unit, and this is a flat bed unit. I also showed you the vertical one is. So this interrelation of resistance, voltage, current, and power. Two basic electrical equations are important in electrophoresis. The first one is Ohm law, that this current is equal to this E divided by R. The second is P is equal to EI. Putting the value of this I in equation 2, this can also be expressed as P is equal to I square R. So in electrophoresis, one electrical parameter, either current, voltage, or power, is always held constant, and the other two are the variables basically. So consequences, under constant current condition, velocity is directly proportional to current. The velocity of the molecule is maintained, but heat is generated. So under constant voltage condition, the velocity slows, but no additional heat is generated during the course of the run. Under constant power condition, the velocity slows, but heating is kept constant. So the net charge is determined by the pH of the medium. Proteins are amphoteric compound, that is, they contain both acidic and basic residues. Each protein has its own characteristic charge properties depending on the number and kinds of amino acid carrying amino or carboxyl group. Nucleic acid, unlike proteins, are not amphoteric. They remain negative at any pH used for the electrophoresis technique. So this is very important, that you should know that at which form your molecule is basically present. So in temperature and electrophoresis, and this temperature and electrophoresis relationship is important at every stage of electrophoresis. So during polymerization, so this the relationship of this temperature and electrophoresis so important at every stage of electrophoresis. Like it is important during the polymerization, uh, whether it is exothermic reaction, gel irregularities and pore size. This depends on the temperature, and also during electrophoresis, uh, deteriorations of proteins, smile effect, temperature regulation buffer. What is the role of solid support matrix? It inhibits convections and diffusion, which would otherwise impede separation of molecule. It allows permanent record of results through staining after run. It can provide additional separation through molecular sieving. This agarose and polyacrylamide, although agarose and polyacrylamides differ greatly in their physical and chemical structure, they both make porous gel, and you know why gel is used in electrophoresis. A porous gel act as a sieve by retarding, or in some cases by completely obstructing the movement of macromolecule, while allowing smaller molecule to migrate freely. By preparing a gel with restrictive pore size, the operator can take advantages of molecular size differences among protein. Because the pore of an agarose gels are large, agarose is used to separate macromolecule like nucleic acid, like proteins, like protein complexes. Because of this bigger pore size, this agarose is used as a gel and electrophoresis technique. Polyacrylamide, which makes a small pore in comparison to agarose gel, is used to separate mostly proteins and small oligonucleotides. Both are relatively electrically neutral gels. So agarose gel is a highly purified, uncharged polysaccharide derived from agar. Agarose dissolved when added to the boiling liquid. It remains a liquid state until the temperature is lowered to. This was just this is just information about agarose gel, because agarose gel and the other one is quietly polyacrylamide is quite commonly used gel in electrophoresis technique. So it's at a lower temperature, about 40 degrees centigrade, at which point it's gel. The pore size may be predetermined by adjusting the concentration of agarose and gel. Agarose gels are fragile, however, they are actually hydrocolloids, and they are held together by the formation of weak hydrogen bond or hydrophobic bonds between these agarose gels. This is the structure of repeating unit of agarose 336 hydro L-galactose. Uh, this is the structure. The basic disaccharide repeating unit of agarose is this one. This is 1,3 beta D galactose, and this is 1,4 alpha 136 N-hydrogalactose. Uh, it's giving, this is the structure. The gel structure of agarose look like this. This is sol state, and this is initial gel, and this is final gel structure of agarose when you are changing it. Like till 40 degrees centigrade, it is in the sol state, and after 40 degrees centigrade, like when initially converting into a gel, like at 100 degrees centigrade, they are completely converting into like at boiling water and into a gel. This polyacrylamide, this is the this acrylamide unit. Now, this is basically a polymer. Poly are tougher than agarose gels. Now, acrylamide monomers polymerize, this is n number of these units into a long chain that are covalently linked by a cross linker. And polyacrylamide is a chemically complex, as is the production and use of the gel. So these two book I will recommend: J.D. Christian, Analytical Chemistry, 7th edition, John Valley and Sons, publisher, Scooge and West, also Fundamental of Analytical Chemistry, 9th edition. So this was all about the electrophoresis technique, different electrophoresis, different gel used electrophoresis technique. Hopefully, in our next lecture, we will discuss what is spectroscopic technique.